To add or subtract radical expressions, the terms must have similar or like radicals. That is, radical expressions that have the same radical factor can be simplified. And on first glance, this first example here, these are not the same radicals. However, an expression may contain like radicals after it's been simplified. So if we look at square root of 45 and use our product rule for square roots, this would break down into the square root of 9 times the square root of 5, since those radicands multiply to equal 45. And likewise, the square root of 125 can be broken down into the square root of 25 times the square root of 5, since 25 times 5, the product of the radicands, is equivalent to the original. By breaking it down this way, we have a perfect square. Square root of 9 is 3 times square root of 5, which cannot be simplified. Square root of 25 is 5, since 5 squared is 25. But the square root of 5, there's only a factor of 5 there, cannot be simplified. After each of these radicals were simplified, we now can simplify further and add these radical expressions since they have like radicals. 3 plus 5 gives us a total of 8 square root of 5 for our final simplified answer for this expression. In the next problem, again, on first appearance, these cannot be combined because they are not similar or like radical expressions. However, let's see if we can simplify them and then combine like terms. The first expression is in its simplest form. However, square root of 8 can be broken down into square root of 4 times square root of 2, since the product of the radicands is equal to 8. And likewise, square root of 18 we can think of as square root of 9 times square root of 2, since 9 times 8, the product of the radicands is 18. Simplifying further, we have a perfect square here with square root of 4, which is a 2. Square root of 2 cannot be simplified further. Moving through the problem, square root of 9 is 3, since 3 squared, or 3 times itself, is 9, and square root of 2 cannot be simplified. We have addition, multiplication, and subtraction. We'll take care of our multiplication first, following our order of operations, which results in a replacement of 6, simplifying our multiplication of those integers. And now looking at this addition of radical expressions, since each one of these terms has the same radical expression, they can be added and or subtracted. So going from left to right, we have 2 plus 6 would give us 8 times the square root of 2, minus 3 times the square root of 2, and 8 minus 3 results in a final simplification of this expression of 5 times the square root of 2.